Hi everyone, we are Pratik and Gunabiram. Our project is about automatically classifying how severe someone's eczema is using deep learning. So, eczema affects around 230 million people worldwide. What makes severity classification so important is that the treatment is completely different depending on grade. Mild cases get typical creams and severe need a biological therapy. Right now, doctor uses manual scoring systems like Scorat. So here is our problem statement for that. CNNs are already great at detecting whether eczema is present. Existing models already hit up 95% of accuracy on that. That's a solved problem. The gap is in grading severity. So here is our approach for that. Our system is a three-stage pipeline. As in stage 1, it asks, even is this even a skin image? That uses a MobileNetV2, whereas a stage 2 asks, does the skin even show eczema? That uses a EfficientNetB0. As in the final stage, which is the focus of this project, classifies the severity as mild, moderate, and severe. That's where it uses the EfficientNetB0 plus CBAM attention models. And here are our two techniques for the stage 3. First, the CBAM, which is the Convolutional Block Attention Module. It adds channel attention, asking which feature maps matter, and spatial attention asks where in the image to focus. In the second, Grad-CAM, which generates heat maps showing which pixel drove each prediction. And coming to our data set, we use the DermaNet dataset from Kaggle. Since DermaNet has no clinical graded severity labels in it, we build them matching folder names and file names against the severity keywords. As this introduced label noise, which we acknowledged in limitations. The class imbalance is real. Look at this moderate, which is having of 1885 versus only 127 for severe. Coming to our architecture, here is our stage 3 architecture, where we started with EfficientNetB0 as the backbone. One important non-obvious detail here we observed is the EfficientNetB0 does its own internal normalization. So inputs must stay in raw or to 2 to 5 range. If you divide by 2 to 5 like you normally would, you would get a class collapse. After the backbone, CBAM applies a channel and spatial attention. Then global average pooling feeds into a 3-class softmax set. We train two phases. First, with the backbone frozen, then fine tune the top 30 layers at each lower learning rate. Data augmentation with flips, rotations, and brightness prevents overfitting on our small data set. So there are our results, where variant A is our MobileNetV2 baseline, which is hitting of 81% of test accuracy, but macro F1 is only 0.47, meaning it's basically ignoring the rare classes and stuff. Where the variant B swaps the EfficientNetB0, which is accuracy is barely changing over here, but F1 jumps to 0.55. Whereas the last variant C adds a CBAM on top, which is hitting of 85%, 85.3% of accuracy, and F1 of 0.62, the key intake. CBAM drives the biggest gain, a full of plus 1.5 micro F1 over the baseline. So here are the example for the Grad-CAM visualization. For one correct classified example per class, red means high attention. For mild eczema, attention spreads across dry, patchy texture. For moderate, it looks into inflamed knee region. For severe, it concentrates on mostly intensively areas. So, three lessons from this project we learned so far is like, first, attention improves both accuracy and interpretability at the same time. Those goals aren't conflicting each other. Second, the label quality beats architecture. Expanding our keyword map added more images than any model change could compensate for that. Third is like the focal loss is essential for imbalance medical data. And here are our limitations as we are transparent about what the system can do. The labels are keyword driven, not clinically verified, as we all know. So this is a research, not a clinical software thing. The severe class has only 19 test samples, so these recall numbers are noisy. And we only tested on dermanet generalizations to real clinical photo is unknown. While concluding, the pipeline works cleanly across all three stages. CBAM gives a meaningful plus 1.15 micro F1 lift, and Grad-CAM confirms the model is paying attention to right things. That's a good thing. The single most impact next stage would be clinical annotated severity labels, and that's a real bottleneck. And thank you for all.